Hello everyone. So in today's session I will be continuing with probability and I will be dealing with verbal description of an event and equivalent set theoretical notion along with conditional probability. Now it's very important as in probability most of the question comes as a word problem and we are unable to write the word into mathematical form and thereby it creates a problem for us to identify which theorem or which law we are supposed to use. Let us start. So let us quickly go through this. Not A can be written in this. So before doing this, I would like you all to go and first study set theory. What is the property, De Morgan's law? What do you mean by intersection, union, complementary? All these terminologies are important for you to proceed with probability. So let's say not A. Not A is denoted by A bar or sometimes as A dash. That is complementary of A. Next is A or B. Now students get majorly confused with or and. Now or is something, just consider an example. Let's say I want an orange or an apple. Right? That means you either give me this or you give me this or you can give me both. Right? Both also works. So or is something which combines this and this both. Along with even if you give me one, that's also fine. So it comes under union. Either you give me this or that. Even if you give me both, that's fine. So it's union. And if you just remember one, the other one is intersection. See, and is something which requires both of them to exist together. If I, for example, the same I will just tell you. I want apple and an orange. That means what? I want both. I want both. If you just give me apple, I am not satisfied. If you give me orange, I am not satisfied. I need both. Right? So it comes under intersection. Now if I have to draw using Venn diagram, I'll just tell you. This part is the intersection. And this whole, this along with this is your union or. Okay? Next is A but not B. That means I want A but I don't want B. So I want A but I don't want B. And the both things should happen together. So it's intersection. Okay. How do we write it? A. I want A but I don't want B. So B bar. But both should happen together. So it's intersection. Next is the similar B not A. B but not A. Same thing. Neither A nor B. I don't want any of these. So A bar, don't want A, don't want B, and both are happening together. Neither nor both happens together. Next is, these are very important ones. At least one of A, B or C. Or, that means it's going to be union. At least one. So A, union B, union C. At least means what? Any one you give or any two also you can give or you can give me all three also. So this is what is denoted. Next is exactly one of A, B and C. Okay, and C. So I need exactly one. So all these three are happening even though I just want one. So how does it work is, I think I have written this one incorrectly. Let me just correct it. Okay, so this is not written in this form. So this is written as exactly one I want. So give me A, but I don't want B. I don't want C also. Union, I don't want A. Give me B, but not C. And then union, I don't want A. I don't want B, but I want C. So if you see, in this case, A is only happening and the other two are not. So exactly one event is happening at a time. Next possibility could be A and B, C are not happening but B is happening. And this is for C is happening, A and B are not happening, and we have to take union. So either this can happen or this can happen. Now next is exactly two of A, B or C. That means two of them will be happening together. So you can see A and B here are happening but C is not happening. So it's exactly word is important. That's why I'm using complementary of C. Now union, you just have to make sure that two events are happening but the third one is not happening. And this all should happen at once. right? That means what? When A and C are happening, B should not happen. So it's going to be an intersection. Next is exactly one of, so okay, I have, so these two are same, right? Now next one is all three of A, B and C are happening. So it's just A intersection B intersection C. I hope it's clear. If you want, you can take a screenshot of this. Now let's proceed with another terminologies. So this can come as in 1 mark. So what it says, the odds in favor of the occurrence of an event A. So whenever I say odds in favor, just remember this word, odds in favor, then we say it is P of A is to P of A bar. That means occurrence of happening of A and not. And when I say odds against the occurrence of the event A, then it's P of A bar is to P of A. Now this notation basically means that M is the number of, so this is basically your P of A, probability of happening of A, and this one is probability of not happening of A. And here N is the total probability, that means the sample space, how many elements are in the sample space, that is N. I hope it's making sense. So here, as I said, favorable outcome to event A is M and total outcome is N. So whenever we say odds in favor, so first favorable outcome to A should come is to not favorable to A, which is nothing but N minus M. Okay, now let's move on with the problem. So the first problem is the probability of the simultaneous occurrence of at least one of the two events A and B. So at least one of them should happen or both can also happen is P. If the probability that exactly one of A, B occurs is Q, then we have to prove this. So this is a proof question, easy because it's something that is already given to you, you just have to prove it, right? You are not finding anything here, you are just proving. So keep in mind at least one of, okay, and here exactly one. So let us first understand how are we supposed to write. Just go through the question one more time and let's start. So I have just written here P, simultaneous occurrence of at least one of A or B is P, and similarly something is given. So these two are given data. Same thing. Now what I am doing is I am writing in theoretical notation. Simultaneously means it should happen together. Occurrence of at least one of A or B. Occurrence of at least one of A or B is what? Either A should occur or B should occur. Correct? So it is A union B. Please don't see and here. It's at least. Either A should happen or B should happen or both can also happen. It's P. Next is occurrence of exactly one. Only one should happen. That means if A is happening, B should not happen. Union. If A is not happening, then B should happen. Same thing also can be written. Other than that, if you look very carefully here, I'll just draw it here. Okay, so let us consider this is A and here this is B. Then which part they are actually talking about is this part. Exactly one of them should occur. So either this part should occur or this part should occur, right? They are not intersecting at all. Now how can we write the same thing? We can write how? A union B, from the total just subtract the intersection part. And that's what we have written over here. Okay, so P of A union B minus P of A intersection B is Q. Now let's start. So I need this on that side. Okay. So why I am writing in this form and not from in the previous form that I wrote over here is I need to involve P somehow in this equation. That can only happen when this term comes. So I made sure that term is over here. Now let us replace. So this is the equation I am dealing with. So replace this with P. Just take it to another side. Now keep in mind I need complementary. Okay. So what I am doing is I am trying to write this into this form. How do you write it? As I told, P of any event P of E plus P of E bar is always 1, right? That means what? P of A intersection B is 1 minus P of A intersection B whole bar. Consider this whole is your E. So this is E bar. Okay. Now using De Morgan's law, I know that A intersection B whole bar is A bar. Intersection will change to union and then B bar. Okay. Now keep on taking all the variables and number to the other side. Now I am opening this. Since it's a union, you have to apply De Morgan's law, that set property, that is P of A bar plus P of B bar minus P of A intersection B bar, which is nothing but this one. In number form we used to do n of A union B is n of A plus n of B minus n of A intersection B. Set theory. I have applied that and it works with probability as well. Now what is this? This is actually 1 minus, okay, I don't have to deal with this because this is what I am looking for. So just keep it separate and take rest everything to other side. Now the only thing is I have to convert this in terms of P and Q. Now the same thing can again be changed and written in this form. Now what is this? This is again 1 minus P of A union B. Correct? Which is 1 minus P, and then you equate it, you will get this. So we have proved P of A bar plus P of B bar is equal to 2 minus 2P plus Q. Now let's move on to conditional probability. Conditional probability is simply an occurrence of an event given that something has happened. Okay, and how you are supposed to read is in this form. P of A by B, how do you read it in a word form, is probability of occurrence of A, whatever is given on the top, given that B has already occurred. So B will come in the denominator. So its occurrence of A given that B has already happened is conditional probability. That means occurrence of this is somehow depending on this. This is the condition given to you and now you have to find what's the probability. If this condition was not given to you, the probability of occurrence of A might be different. Now what's the formula? P of A by B is P of A intersection B by P of B. Now how do you remember? Very easy. Whatever is in the denominator, probability of that will come here and you take intersection of both. The only part here students sometimes get confused, what will come in the denominator. It is whatever is here in the denominator, that same term will come. Let's understand using problem. Now this problems has come frequently even in pre-boards and boards. Let us see what this problem is. A couple has 2 children. Okay, find the probability that. So 2 children are there. Now what is given? First is both the children are boys. I need to find the probability that both the children are boy if it is known that the other child is a boy. That means what? I need to find some probability given that it is known, given that this thing has already occurred. Okay, now since 2 child are there and they are talking about 2 child, so here what will happen is you are going to get 4 elements in the sample space. Why? Look here, so let BI and GI denote the girl, that means in the order. That means B1 means the first child, B2 is the second child. Okay. Now let's see. So as I told you, so B1, B2 means first is a boy, second is also a boy. B1, G2 is first one is a girl, second one is a girl, second girl. And here G1, first girl and the other boy. G1, G2, first girl and second girl. Okay. Now let's see how we are supposed to do. Let us say, let A be an event. What is given? Other child is a boy. Okay. I need to find both the children are boy, other child is a boy. So A is both the children are boy. This is what I need to find. So this will come in the numerator. Given that other child is a boy. Sorry, it's not other, it's older. Okay. I'm really sorry. Let me correct that. So it's older. Yeah, it's older. See, now the question comes here is students get confused. Why can't we just take B1 and G1? This should be a sample space, right? But after reading the question, you will understand that they have introduced this term older. So they are talking about the order as well, younger and older. That means I am supposed to take 2 boys and 2 girls. Okay? See, if I just take 1 boy and 1 girl, how will the order define? It will just define BG or GB, that's all. First is a boy, second is a girl. First is a girl, second is a boy. What about boy, boy? Now I can't take both BB, right? I just need to differentiate. I need something to differentiate, and that's the reason we have gone with this index. Okay? So I need to find that what is the probability of occurrence of both the children to be boy given that the older one is a boy. Okay, so both the children are boy is what? B1, B2. It's not comma. There is no comma here. It's B1, B2. One second. And the older child is a boy. So older means which is coming first, B1. Starting is the older. So here also older one is a boy. Here also older one is a boy. Now let's come. What is A intersection B? It's a set. Few problems can be done using set. This is pretty easy. So number of elements in A intersection B is 1. Number of elements is B. Just substitute over here. Right? So don't get confused from where n is coming. It's simply P of A intersection B is n of P intersection B, A intersection B by n of sample space, right? Same thing will happen here, n of B by n of S. So this thing eventually get cancelled and you will be left with this by this. So I am directly writing it. The next question is, both the children are boys. This is the probability that I am supposed to find. Now what is given? That at least one of the children is a boy. So here order does not matter. Right, at least one of them is a boy. So either younger or older. But I need to find both the children are boy again. So my A remains same, both the children are boy. That means B1, B2. At least one of them should be a boy. So here one of them is a boy, here also one of them is a boy, here also one of them is a boy. Now same thing will happen. A intersection B is only one element, so 1. And n of B is what? 3. So 1 by 3. I hope this question is making sense. The only reason we are taking B1, B2, G1, G2 is here order matters. Older, younger concept is coming, and that's why we are supposed to take in this way. Let's come to the other question, which is very easy and commonly asked again. An urn contains 5 white ball, 8 black balls. Okay, so 5 white ball, 8 black balls. Total we have how many? 13. Okay, 13 balls are there in total. Now, 2 successive drawings of the 3 balls at a time are made. So, 3 times you are going to pick balls. That too successively. Such that the balls are not replaced before the second draw. That means the first time when you are picking, you have total 13 balls in the urn. But the second time when you are picking, you are left only with 12 because I am not replacing it with the ball that I have already picked. And the third time when you are picking, only 11 balls are left. Okay? Find the probability that the first draw gives 3 white balls and the second draw gives 3 black balls. Okay? So what is given? Find the probability that the first ball gives 3 white balls, the first draw gives 3 white balls and the second draw gives 3 black balls. Now let us see how we are supposed to do. Let A be drawing of 3 white balls in the first draw. That means the first time all the 3 are coming. Second is drawing 3 black balls in the second draw. All 3 of them are coming. Now what I am supposed to find? P of A intersection B. Now what is P of A intersection B? From the conditional probability formula, I can write it as P of A into P of A by B. Right? So what is P of A? So let's come and use some combination permutation concept. How many balls I need to draw? 3 out of 13. So in how many ways can I draw? 13C3, right? What I am supposed to draw? 3 white balls out of how many? 5. So it's 5C3. Now when you solve, you will get this. Okay. Now after drawing 3 white balls in the first draw, 10 balls are left. Agree? You are drawing 3 balls. After that, 10 balls are left. Now out of those 10 balls, again you are picking 3 balls. So number of ways you can do that is 10C3. What you need now? You need 3 black balls out of how many? 8. So 8C3 by 10C3. You will get this. What you are trying to find? That you need 3 white balls first and then you need 3 black balls. Right? So what will happen here? It is going to be product. This thing is happening along with this thing is happening. When two things happen together, it's AND, correct? And that is using product. If you have learned permutation and combination, you won't suffer here, because here a bit of that concept is also being used. Okay, so it's going to be product. Intersection comes, it's going to be a product here. Okay, so I hope this question is making sense. So I think you're able to understand. I will repeat one more time. You have 5 white balls and 8 black balls. 2 successive drawings are happening. So 2 times you are picking. Okay. First time you are picking 3 balls, and the next time again you are picking 3 balls. When you are picking for the first time, 3 balls are picked at once. That's what they are doing actually. Even from the previous concept, if you do what I said, you will get the same answer. Okay, so when you are picking 3 balls, after that again you are picking 3 balls, but for the first time when you picked, you had 13 options, but the next time when you are picking again 3 balls, you have only 10 options. And they are asking us to find what is the probability that the first draw gives you 3 white ball and the second draw gives you 3 black ball. So in the first draw itself you are picking 3 balls, keep that in mind, and second draw again you are picking 3 balls. Okay, so in this case we are using the probability concept, conditional probability concept over here. Okay, see, this is where we are using probability of picking 3 black balls given that already 3 white balls are chosen. Okay, and depending on that, now I am not using that formula, that is P of A intersection B by P of B. What I am doing is, I know that A has already happened. Since A has happened, I am left with 10 options, and out of that I have to pick 3. And what I am supposed to pick? Black balls, 3 black balls out of 8. So this is what we are doing. The same concept is being used, but I am not using that actual formula where I have to put the probability and probability thing. Next question. 2 integers are selected at random from integer 1 through 11. So you have total how many choices? 11. You can choose from 11. But how you are supposed to choose? Let's see. If the sum is even, find the probability that both the numbers are odd. So this is given to us. This is the probability that I am supposed to find. So it comes under conditional. Something is given. Based on that you are being asked to find the probability. It comes under conditional. Okay, now let's see. Out of 1 to 11, you know even are 5, odd are 6. The concept why I am asking to write even and odd is, not any 2 number being added will give you even number, right? So how does it work? When you add 2 odd, you will get even. When you add even, you get even. When you add even odd, you get odd. So I am supposed to get what? If the sum is even, I need to tell the probability that both the numbers are odd. This one. Sum is even, I need to tell the probability that both of them are odd. Okay. So let A be, both the numbers chosen are odd. B be, the sum of the numbers chosen is even. Okay. So what I am supposed to find here? I am supposed to find both are odd given that the sum is even. This is what you need. Now you can write the formula and then you proceed further for finding. Now in this problem I am again using combination concept. Okay. Now Probability of A. Now what is A? Both the numbers chosen are odd. Okay, I need to choose two numbers out of how many? 11. So 11, see two ways you can do that. You can just choose. But in that I want what? Odd numbers. How many odd numbers are there? 6. So out of 6 you will choose 2. So this is probability of occurrence of A. That means choosing two odd numbers. What is probability of B? Probability of B is I need to get two numbers whose sum are even. Now that can happen in these two ways. Both are even or both are odd. Okay, that means what? Out of 11, two numbers I need to choose. I can do in this way. Okay, now ways. I can choose two numbers from the 6 odd numbers, or means addition and means multiplication. So or I can choose two numbers out of the given even numbers, that are 5. That's why plus is coming and not multiplication. Okay, because they both will give you what you are looking for. They both are not occurring together. Occurring together only will be product. So what is A intersection B now? P of A intersection B is choosing 2 out of 11. This is the number of ways you can do, but here you are choosing both even and odd. Here you are only choosing odd, right? So intersection will be choosing only odd. Now let's come over here and substitute in the formula and you will get the answer. In case you don't remember what is NCR, it is n factorial by r factorial into n minus r factorial. Okay, I hope it's clear. One second. So 2c1 is equal to 2 by 1, that's 2, but if it's 2 factorial, 1 factorial, yeah, 3c2 is 3 into 2, 2 into 1, so it's 3, or is it 3 factorial, 1 factorial into 2 factorial, yeah, that's correct. Okay. Okay, so in next class we will be starting with few more problems. By the time, just go through this session again. If you have any doubt, please ask in the comment section. Please like, share and subscribe.